It's a mystery that has beguiled mankind since the beginning.
Ultimately, what we're trying to do is ask profound questions like, are we alone in the universe? And if we found that answer, that would be a transformative moment in human history.
The last 25 years have been transformative. When Hubble was launched, the only planets we knew about were those orbiting our sun. But for the past decade, astronomers have discovered a rapidly growing number of so-called exoplanets, whirling around other stars as well.
Well, the main way we found planets right now is by the transit technique. And that is when a planet goes in front of the star as seen from the telescope, the starlight drops by a tiny amount, by 1% or even less. And by measuring a star's brightness, minute by minute or hour by hour or day by day, we're able to spot a planet transit.
While Hubble can't take the credit for actually finding these transiting planets, their discoveries gave Hubble astronomers a never-before-imagined opportunity to determine what's actually in the atmosphere of an exoplanet, too far away for us to visit.
The analogy I really like is looking at a rainbow. If we could look at the colors very, very closely, we would see tiny, tiny dark lines, many of them, spread all throughout the rainbow. And those lines are caused by gases in the atmosphere absorbing radiation. They're essentially taking out some of the light in the rainbow. And with Hubble, we do the same thing. We take the light from a star or planet and spread it out, and we look for places in the colors where light is missing. And because each gas has its own fingerprint or its own distinct set of lines that it removes from the white light spectrum, we're able to identify what gases are in the atmosphere.
It's taken us from just measuring basic properties of the planets, like their mass and their size, to actually allowing us to study the atmospheres, and therefore maybe giving the planets a bit of personality.
And as it turns out, those personalities are not like the ones found in our solar system.
There's this incredible diversity of architectures, of where we find the planets relative to their stars and what the planets in fact look like. I think it's Hubble that's really made them all kind of unique worlds for us.
Worlds that intrigued us even more when Hubble's last servicing mission started paying dividends.
We have new instruments on board Hubble since 2009. In particular, an instrument called the Wide Field Camera 3. We're using it to measure the water abundance in planetary atmospheres. We're using it to study the temperature structure in planet atmospheres. And we're using it to study weather patterns on exoplanet atmospheres.
But right now, Hubble is only really telling us about the atmospheres around giant planets, many times larger than our own.
So in some ways, we see the giant planets as a stepping stone to see if we can observe them and understand them for our future quest for life beyond Earth.
What we want now are smaller planets, planets that are perhaps more like the Earth, and planets that pass in front of very close stars, the very closest stars for which we can find those planets, because they're going to be the easiest ones to study.
Studying those smaller planets is what's on the docket for Hubble's successor, the James Webb Space Telescope.
We'll be able to probe the abundances of different molecules. Right now, we're mostly sensitive to only water, and water is very important. But there are other molecules that we want to know the abundances of too. Carbon monoxide, carbon dioxide, methane, ammonia. These are very important molecules from the standpoint of planetary atmosphere physics and the formation of planets.
Planets that may hold the answer to whether or not we are alone.
I'd say my dream is to start my career as an astronomer and to end it as a biologist. So what I would really like to do is get at the question of life in the universe.
I do think there's life out there somewhere. Our galaxy has hundreds of billions of stars, and our universe has upwards of hundreds of billions of galaxies. So the chance for life to exist out there somewhere appears to be inevitable. A harder question is there life somewhere near here, a planet orbiting a nearby star that we actually can look at closely? That's a much tougher question.
Tough questions we are on the cusp of answering because of the Hubble's pioneering work. From the Space Telescope Science Institute in Baltimore, Maryland, I'm Mary Estacion.